centimeter in pi. Will these be the same for everywhere? Yeah. What happens as you go deeper?
Changes.
Phi increases. Why? Why does phi increase? Yeah, soil will be denser. Okay. So if they are denser, the friction will go up. What do you call that?
Interlocking increases.
Dilation? Maybe? Or lack of dilation? Anyhow. Right. So you got these strength parameters, and maybe you divide this into many layers and ascribe the strength depth. So what do you do next?
Find the load capacity of a single pile.
Hmm?
Find the load capacity of a single pile.
Yeah, that's what I'm trying to work out. That's how we designed it, right? So you start by assuming some diameter, maybe. Don't feel shy. I'll correct you if you're wrong. We're among friends. Nobody is saying you.
Work out the skin friction and the end bearing system.
Thank you. So you want to try and work out the skin friction. And how do you do that? And the end bearing. That's the big arrow. So how do we work that out? Somebody is mumbling. I have a cold. I can't hear. Speak up.
Depending on size, type of soil will change.
Okay. So let's say get rid of this. You only have that. So it's a sandy soil. Let's say. Then the skin friction. You're trying to work out the horizontal stresses and apply a factor to work this out. Yeah. So effectively, what you're saying is I'm going to multiply that with some. Yeah. And I'll multiply that with some. And delta should be the interface friction. What about this? And where? QB, yeah. So this is a skin friction component. Sharp. How do you work out end bearing?
Generally, the bag is
Hmm? Speak up, please. Generally, somebody was saying
Bearing.
capacity.
bearing capacity equation. So where I come from, you don't need to worry about remembering bearing capacity equation. If you know that the failure mechanism for this is always going to be like that. So the soil has to shear get to that shape, then you know from upper bound and lower bound analysis that the factor is always going to be about so what you would call n gamma is approximately 9ish. So deep failure mechanisms always mobilize something like 9, and you can do upper bound, you can do lower bound, and they match quite nicely. So plasticity is the way you do that. Not so much the Terzaghi's bearing capacity factor. You don't have to do it. So that comes about 9 times the CU value. SU or SU, whatever it is. Yeah. If it is sand, you'll find the equivalent of that, and it will be okay. There are some simple things you can do. So we work out QB, work out QS, and try to have the design. So you choose the diameter to carry the load you want, or the length. Those are the two variables. What factor of safety do you design files for? One, so you clearly haven't worked in the field. You're a student. 2.5. Yeah. And thus, the funny thing goes on this is with all these calculations, the factor of safety is 2.5. No other geotechnical structure you build will have a factor of safety like that. Only pile foundations. If you do embankments, slope, stability of slopes, you go for 1.25, 1.3, depends how brave you are. Yeah, shallow foundations, maybe 1.5. Most other retaining walls, maybe 1.5. Even Eurocode 7, which applies load factor of safety approach, but you factor the strength parameters rather than the overall load factors like this. But pile foundations are unique in that we are so bloody unsure of them under static load. And here we are trying to work out what they're going to do under earthquake loading when the ground is liquefying, all kinds of fancy stuff. Actually, there is so much uncertainty with the pile foundations. There's a very interesting exercise that Imperial College has carried out about the site characterization for a particular location. And they said, we're going to drive a pile into this ground. Please make your estimate of the ultimate capacity of this pile, load carrying capacity. We'll do the load test afterwards and come here. And many people had a go, from students to professors to construction companies, everybody had a go. And many people used things like this, which you can. There's nothing stopping you from doing that. In fact, that's what codes of practice said. And the results were startling from quite eminent people getting it completely wrong to some fluke solutions who basically did just that, but chose the right phi value and c value, miraculously ending up with the correct load. And what the conclusion of that study was that there's significant uncertainty about the load carrying capacity of piles. And there's some very nice papers that came out of that comparison exercise as well. It's quite right to have a go at these kind of things, but one thing you must remember is the reason engineers use this big factor of safety against 2.5 is you're not sure of so many things. Partly, or mostly estimating the C and phi. I put the C, you'll never see that. And it's not good enough to estimate that at some one depth. You really need to know this profile with depth, which often, but almost always, not done. You probably go for some representative depth and say that's what on average it's going to be. Whereas in the site, even in the one site, if you're driving piles, they may be encountering quite different strata as you go into the ground. That's one problem. The other problem is if you're driving the pile, any piling engineer will tell you, they don't go straight in. There's no such thing as a vertical pile. They have worn them. So a pile, which is, if you aim to drive it like that, may end up like that. This could be as much as a meter. That's called file wander. So that's another answer. Sometimes it may increase your carrying capacity also. But in other times, when if the ground around it liquefies, it causes other problems. So verticality is an issue. Drivability is an issue. Uh, in the UK, we mostly do board files because it's mostly clay, London clay. And then you almost always ignore this. You only have to go like this. Because whatever skin friction you have, you basically, the horizontal stresses are all relieved when you made the hole. So you haven't got much horizontal stress unless the concrete expands and creates its own uh, horizontal pressure. So we have to entirely rely on anchoring. I don't know whether files here are predominantly board files or driven files, but I guess combination of both is big difference. So you will need both. And it's a it's a mug's game, as they say in English. Uh, with so many files being driven around the world, even 1% improvement, if we can all confidently use 2.4 then 2.5, just do the calculation of how much money you would save in just India. Massive. Because every time you're driving a file, you're saving 10% after that. A little bit less than 10%, but it's a big sale because there are so many files being driven. Okay? So there's enough research to be done there. One thing where I'm going to start after tea, I assure you, is not to do this. Okay? So we should all get in line and try to design the files not based on what you have learned in undergraduate courses, but what the soil is actually telling you. Please try and do CPT. At least in Europe, most file design is now based on the CPTs. In the States, they're a bit backward and they still use SPT, but even they don't use CPI. Okay, so certainly CPI is long gone. Let's forget the CPI soil mechanics. SPT, if you are being a bit silly, but this is an easier test to do. But I have witnessed in my hometown, Kakinada, how they're doing these SPT tests. My God, I wouldn't touch those n value numbers with the barge pole. They just have no idea how to do the SPT test. So the numbers that are being spewed out, you can call them random number generators. N of 10. Really? The thing is not actually going in. The guys are sweating, pulling the weight and dropping it, and the supervisor is recording the number 10. And 10 means it's quite significant. If the n values are 10 or less, you would consider the soil to be liquefiable. And I can't begin to express my disappointment on that. With CPT, at least it's an automated process. So the load cell tells you the cone factor, cone resistance, and we can go somewhere with it. So after T, we'll start looking at how files should be designed based on CPT first, just for static case. At least let's start at a reasonable level, and then we can see what the earthquakes and the rest of it is. Okay? Have some tea.